A car is moving so that its position function is given as s of t equals t cubic minus t.
Hi, Canon.
Hi, we're the team number 6, and today we are going to present the problem number 6. That says, a car is moving so that its position function is given as, and we have this function, that is s of t equals to t cubic minus t. Then we have to expand our formula. We have to add an h for each t, that is s of t plus h equals t plus h at cube minus t plus h. And we can divide this formula by parts. That's the first part, that's our second part, and that's the third part. Then we have to solve this cubic binomial with notable products to obtain a perfect quaternomial at cube. So we have this first part of the formula that is the same, s of t plus h, that is equal to the first term at cube, that is t cubic, plus 3 times the first term at square times the second term, plus 3 times the first term by the second term at cube, plus the second term at cube, minus the third part of our formula that says t plus h. Then we have to use the formula of the derivative that says limit when h belongs to 0, that is equal to s of t plus h minus s of t over h. Now we obtain the result of this binomial cube, and then we have to add minus t at cube plus t, because the formula of the derivative says it. Now we can eliminate this t at cube with this t at cube, and this t with this t. And now we have to substitute when h belongs to 0, and we have 0 over 0. Then we have to factorize this equation, and the common term that all the equation has is the h. So we have to get out the h, and then we have to eliminate this h and this h. And then we have to substitute another time when h belongs to 0. We have to substitute h by 0, and then we have that the result of our derivative is 3t squared minus 1.
To do the exercise B, first we need the original formula, that is s by t is equal to t cubic minus 1. Then we need to substitute the t, that is equal to 1. Here is s by 1 is equal to 1 cubic minus 1. Then we solve, and this is the result. X is equal to 1 and y is equal to 0. Always we talk about y is equal to s and x is equal to t. Then in the second step we use the derivative formula, that is s by t is equal to 3 by t squared minus 1, and then we substitute the t equal to 1, and it's s by 1 is equal to 3 by 1 squared minus 1. We solve that, and the result is 2. Then in the third step we have to find the slope. The equation is this: m is equal to y minus y1 over x minus x1. So we substitute 2 minus 0 over 2 minus 1. The slope is 2 over 1. And then for the fourth step we use this equation 2 by x minus 1. The result is minus 2. So the y is equal to slope by x plus the y-intercept. This will be the x is equal to 2 by x minus 2. And this is y tangent is equal to 2 by x minus 2.
Obtain the equation of a normal line, we know that it's a perpendicular, so also we fill the number and change the sign. line is equal minus 1 over 2x plus y over 2.
In the first graph, we can see our first function, that is s of t equals t at cube minus t. In this graph, we can see the equation of a tangent line to the position function at t equals 1. In our third graph, we can see the equation of a normal line to the position function at t equals 1. Here we can see that both lines are perpendicular, and then we can infer the importance of the tangent line and the importance of the normal line, that are 90 degrees separate each other. And finally, here we can see the three functions that we use.
Bye, Carlos.